I'm recording the second and final vlog for the construction of the stealth video game that I set out to work on at the beginning of this year and beforehand during the research process. And I'd like to use this video to, as briefly as I can, go through the key elements of what I built throughout the game and just go through some of the sort of learning experiences that they brought along with them, and also just to highlight some of the design choices I made and connect those with my general framework for the construction of video games. Without further ado, I'd like to get started, but there's one quick note, which is that this was wholly a community effort. Nothing I've done here would have been possible without the help of Owen Goss, my advisor from Milkbag Games, who helped guide me along in this process, from Matthew Fagan and all of his help throughout, sort of nudging me along on the project management side of this, my professor for the classes this is for, and even just more broadly to the game development community. All of the YouTube tutorials, all of the documentation given, all of the helpful late night answers on Unreal Engine forums were all monumental in making sure that I was able to sort of chase this dream of mine. And now I guess just it's time to dive straight into the process of showing what I've done here. So here are what we have are called the blueprints, which are sort of like the inner workings or mechanisms behind the assets seen in an Unreal Engine game. So where in the window editor here we have what I've actually built, and sort of closer to the final product of what a level looks like. The blueprints they're the functions that determine how objects interact with the rest of the world around them. The first blueprint that I like to focus on, just to show sort of where my work started, is with the third person blueprint. Now, this is the blueprint that decides how the character works. It's how the player is able to interact and explore the game world. It's how they make the character run, jump, all those sorts of things. And it's also a good place to start because it shows maybe the simpler side of working in Unreal Engine. So if we zoom in here, for example, let's look at the pickup action. That's a really simple one. So what this does here is it integrates a function into the world in a way that basically my inputs on the keyboard can directly translate into changes on the screen. It starts with the push of whatever button I've assigned. In my case, it's the V key. It could be any key, to this action I've titled pickup. And then from there, when this executes, it's going to take data from an array of all of the possible items that the character could pick up in this world. And then from there, it would go through and do a branch just to test of whether or not this character has an inventory, and then whether or not this item can be picked up. And if the character tries to pick up something that can't be picked up, then it's going to print to the screen, you can't pick that up. Otherwise, it's going to run the pickup item function, which sets the value of has rock, which is just to decide whether the character has picked up a rock or not, to true, and then it adds that item to the inventory. And then finally it prints the string, you have a rock. I chose this function just because it's a very simple demonstration of how Unreal functions work. If we'd like to go over to see perhaps a more complex function, just as an example, we can look at the throw function. So for throwing something, it shows how this can become a labyrinth pretty quickly. While working here, I had to learn about all of the different branches of different functions of if the character wants to throw, they need to check, do they have a rock or not? From there, if it's true, then it prints Geronimo as a way to signify the character is able to throw it. And then it plays the animation of the character throwing it. And then from there, I won't go into all the complexities, but it just sort of shows how labyrinthine these processes can get. And I wanted to highlight this because it demonstrates a connection to my underlying work throughout my degree of learning to work as an object-oriented programmer and as a functional programmer. What this demonstrates here is a really useful interface is what all programs fundamentally are, is that they're a collection of various functions, or in a more complex object-oriented program, they would be classes that break down into individual methods. But fundamentally, it's about deciding what goal you would like to accomplish and what information you have and how to draw the line from A to B. It's always about input and output. And as we can see here, we have a simple input being the player touching a key on the keyboard, and then through all of this complexity, we're able to get to, as you can see here, there's the physics of creating a rock and adding force to it and all that stuff. And no matter how complex it is, ultimately the rule is that that input has to correlate with specifically one combination of outputs. The next place that I'd like to hop into as just a quick, this is by no means a comprehensive overview of what I've done, but just as a quick show of the other kinds of work that I've done throughout this development process, I'd like to jump into the materials panel on the graphical side. So this is the average, basically like blueprint for a texture that would go on an object. This one, in this case, is grass. If it were a tree, it would be bark. If it were ice, it would be, basically input whatever texture. These start out as simplistic images, but throughout a sort of complicated process, what's done here is that there's several of these values inputted into key components of what makes the texture what it is. For example, I'll use a bit of a simpler one to demonstrate this. In the bricks texture here, as we can see, it looks like the images aren't quite loading on these, but it shows how what I need to do is load in different images that represent the base color of what the bricks are meant to look like, which is sort of just the image itself. And then other files that I input plug into things like the roughness, which decide how poorly or how successfully light can reflect off of different parts of it. A different file is going to talk about the depth of it when it's rendering shadows onto these objects. And finally, the texture coordinate node is really important in telling it how to tile the texture. If I attach it to a really, really large object, is it going to tile 100 times, 1,000 times? Is it going to stretch the image? So this just goes to show sort of, now I will admit I had a lot of experience with this particular aspects beforehand starting the project, but this was still really valuable for practice and for being able to really interact with and engage with a lot of the different experiments that can be done with lighting and with normal maps and textures and all of that. The next component that I'd like to demonstrate without making this video 10 hours long is just going into the Guard AI process, because I think it highlights a lot of the more strategic thinking that goes into building a game, and it highlights a lot of the, I'll say, interdisciplinary, I think that would be the word, aspects of what goes into to building a video game. So we're going to start with this handy behavior tree. Now every guard, every enemy in this game has a fundamental logic that they're going to go through. The root is basically just the plug-in of starting the logic when they first turn on, and then the selector is going to tell them what kinds of choices they make, and it's going to go through all of these branches for the character to decide what they would like to do. For my guards, what I did is I had them programmed initially with a sequence where what it does is it's going to find different points in the world that have been assigned as its patrol points, just in its default state. So by default, the guards are just going to walk to where they're told to go, and then they're going to maybe change rotation to look around, maybe wait, in this case for 4 seconds. It could be any amount of wait time assigned to this variable. And then finally, when that wait is over, they can wander to their next path point. And the break in that logic that occurs is if the main character, for whatever reason, triggers the guard's AI perception in the forms of hearing or in the visual component. So if that gets triggered, then the guard is going to, if they hear a noise or see something, they're immediately going to, based on these conditions, they're going to run straight to where it was. And then if it turns out that the guard actually confirms that it saw you, the first-person character blueprint, then it actually reassigns from trying to find your location to just finding you itself. So it won't just go to where you made the noise or made the visual effect. It's going to go directly to where you are and chase you around the board. And if it catches you, then that's game over. And then this final component is just an extra layer of logic in case something goes wrong or there's some sort of glitch or possible shorts. I guess I'm blind spot in the earlier programming here. So yeah, that demonstrates, and then connecting in with each of these actions to chase the player, I just like to show how the guard AI sort of works, and just to kind of go into what I was able to learn about artificial intelligence and how the designs of these things work. So what this starts with is there's the event graph here, which basically assigns that whenever the AI, artificial intelligence perception, is activated, it's going to send all of the stimulus data into this function built here. And within this function, what it's going to do is I'm not going to explain every node on this tree because that would take forever. But what it does is it's going to check of whether or not it's detected something through sight or something through hearing. And with both of those, it goes through this to set the value of is investigating, which was the condition we looked at in the tree earlier, to true. And then it's going to branch off to see whether or not it's found the player. And if it turns out that they've actually sensed the actor, then it's going to set value as vector, which is math speak for to set the target's destination away from the patrol points to where the character is. And for time's sake, we're gonna move on from this to make sure that we're not bogged down by all of the algebra here. Although this is very interesting as something to delve into. The final aspect that is that it might seem arbitrary, but I feel is actually worth focusing in on because it shows again just how the different aspects of a game are connected to one another. It's a minor aesthetic detail, as it might seem, but it's the footstep sounds. Now, this was not my idea. This was inspired. I should also say the artificial intelligence basic framework wasn't my idea either. I have the internet to thank for that, but I set it up so that whenever the player's footstep animation hits a certain point, it's a little bit laggy right now, but whenever their foot touches the ground in this animation file, that what it's going to do is it's going to send that information to the blueprint of that character, and then it's going to do a line trace directly into the ground below. And with that line trace, it's going to retrieve the data to find exactly what kind of surface it was walking on. And then with this bridge function here, if it's walking on each different surface, it can play the sound file associated with that footstep, which is really important in a stealth game where the amount of noise you're making keys directly into how detectable you are. So that was an interesting, what in most games would be a minor detail. For example, if we were making a first-person shooter, this might not be the best use of time for a solo developer. But in the case of a stealth game, I felt that this additional work was necessary for the sake of the sound design of really hammering in that that mechanic to give that player that strategy. And then, yeah, of course, it plays the sound of whatever it is. And we're going to see that when I play the game and show off how exactly this works. So that's some... you folks have spent a lot of time looking at my gray grids and functions and physics math. But, I mean, I think the best way to showcase my work would just be to go straight into what the game actually looks like. And with that being said, we are going to do one last save of these files, just in case there were any last-minute changes that I made before recording that I've forgotten about. And then we're going to exit this. Yes, I would like to apply the changes to the modified material. We're going to exit this because... just a little bit of... looks to be something that hadn't been applied properly. We're just doing that to save GPU time so that when we play the game it doesn't run at 7 frames per second. I'm also going to go ahead and just quit Firefox because we know that can eat up a lot of GPU and the settings too. Unfortunately, we weren't able to put too many guards in the world to demonstrate my mechanics because my computer would melt into the desk if I attempted to to flood it with too many enemies. But I think that the concept still stands. So right now we're going to begin playing. So, as we can see, he's a little bit hazy, but we have a guard character over there, and if we begin making tons of noise and running around, he is immediately going to hear me. He's going to post that notification that says, I can hear you, and then, because he caught up to us, it immediately reset the game. Now, unfortunately, that was somewhat of a laggy run. I think it's still shutting down the processes from the other blueprints, but it still just goes to show how, just sort of a simplistic show of the AI. However, if we go to play, and instead of, say, running around making a bunch of noise, we stealthily crouch, it prints that 0 there as a notification that the crouch was working. I left these debug elements in just to sort of showcase the emphasis being on process of how, originally the height of the character at a certain point was just printed to the screen before the animations were imported. And now, with us crouching, if we move really, really slowly, we can actually sneak past the guard without him noticing us at all. Man, this is a little bit on the laggy side right now. It was functioning fairly well earlier. And now, by crouching and being really, really quiet, we can see that the character... now we're going to hang out here for a second, just off to the side, and we're going to see how he's just doing his patrol path right now. He hasn't been targeted, he hasn't been told, to come chase me yet. Right now he's just, it looks like he might have spotted us. So we're going to sneak back into here, because if he sees us for too long, he's going to know. Okay, good. It looks like he didn't notice us. But it just goes to show, the guards are sort of traipsing around right now. Now we're going to take the stealthy route through the shadows just as a strategic decision, and we're going to see what we run into. Looks like we have a very, very low resolution rock right there. And if we pick it up by pressing the V key, it says picked up item. And then, looks like standing up alerted this guard. But now we can see that at this point we have to run away, except the guards are much, much faster than us. And when the guards are much, much faster, that means that he catches me and he deletes the game. To spare time, I'm not going to run all the way through, but there is also a small animation sequence of just tossing the rock as a diversion for the guards. But I think that the key point of this level has been demonstrated so far. And the just sort of the work that goes into making something like this. I should say that not all of these, in fact, most of these assets weren't built by me myself. That's important to understand that like the detailed art of the texture of this gate is someone else's work. It's not mine. Which should just be highlighted, that many games rely on the foundation of there being a very, very large public domain, royalty-free pool of anonymous developers who are just willing to share their 3D assets with the world. And I think that demonstrates the gameplay aspect of this. In the final minutes of this video, I'd just like to talk about sort of what this project has taught me. First and foremost, I would say it taught me about I use this word a lot, but the symbiotic relationship of all the different elements in the game. I originally didn't quite appreciate how much the aesthetic decisions tie into the gameplay, because after testing this over and over and over again and finding what kind of lighting works, what distracts the player, what directs the player, what misdirects the player, there's reasons that there's lights and torches in all of the places that there are, because that's actually what guides the player towards each goalpost. There's a reason that the guards have flashlights, because it indicates not just that they're searching for you, but it's also important as a way to sort of signpost to the reader, or rather to the audience, that's where the enemies are. There's a reason, if you've read through the thesis document, that the lights for the guards are red, whereas the lights for the posts are in yellow, the yellow torches, because those have different psychological significance to people, and also just a lingo in gaming of red representing danger. There's also, as I alluded to earlier, the sound design element of just knowing, it was a tough decision, but knowing whether or not to put music in this game or not, and opting not to because ultimately I felt it would distract from the eerie feeling of the landscape, and distracts from the important sound design of the facts that the different characters have to, the different players have to, just know what kind of surface they're walking on. Which reminds me, I'm just going to quickly jump back in here, see if I can sneak past the guard. I just wanted to show off one detail to point out what I'm talking about, which is that when you're running on grass, it makes the loud grass sound. Crap, I got caught. Here, I'll try, give it one more try. Is this running slow? Looks like I got caught again. Well, I guess I'm not good enough for my own game yet. But I was just going to show that when you walk on sand or stone, then it plays a different sound. Just as an important, an important showcase of the facts that players need to make conscientious decisions of where they're going to walk in this kind of game. And yeah, I think I'm in the interest of sparing everyone time, I'm gonna start closing this off right now. But if you have any questions, feel free to comment. Feel free to email me. I have my email posted. And I'd just like to thank both Owen and Matt for all of the help that you guys put into this to make sure I was able to fulfill this, and just all of the feedback throughout making sure I could stay on time with this project and allocate my resources adequately. And yeah, with that, I'm going to sign off and wish everyone an excellent day.